All right, I am Anthony Emmons here to present Unit 4, Lesson 7, Calculating Unknowns with Percentages. So as I said in the interview, I like to start with the do now. Having not been there with students in particular, right, I'm trying to figure out what sort of strategies they have to find percents and such. So something like find 20% of 60. Do they find 10% because they can do that really quickly, 10% of 60 being 6, and then they double it, knowing then 20% of 60 is 12, or do they equate 20% to a fifth, and then they're finding a fifth of 60, either by dividing 60 by 5 or multiplying fractions? What strategies do they employ? Similarly, 50% of a number is 36. What's the original number, right? Do they know to divide by 0.5, or do they sort of reason through it? Well, if half of a number is 36, what's the original, and know to double? How do they figure these things out? And then the last question, just trying to see if they, what they know, right? It's 75% as a decimal, 0.75 as a fraction, 75 hundredths, 3/4, etc. After practicing that, talking about some of their strategies, taking note, trying to figure out what I can use during the lesson, or if there are any particular strategies I might need to steer them away from for sake of this lesson. That's what I'll do during that time. But after that, I'm introducing the objectives. First being to calculate the original amount, given the new amount, and a percent change for one-step problems. Trying to review. You'll see how they're explaining. Yes, you can do percent change in 2 steps even, but really trying to encourage them to create that as a one-step problem, so that there's that sort of reversibility is more manageable. Same with the second objective for multi-step problems, showing them that you don't necessarily need that intermediate step, and you can kind of combine these things to then better see the reversibility. And just kind of streamline some things. So with that, I took this from Desmos. Percent increase. What do you notice? I just playing the animation, give them some time to view the animation, to engage in a turn and talk, get some low level engagement. Just you're looking at this video. What do you see? Right. Talk to a neighbor, share your observations, and then we will talk it through as a class as they're sharing out their observations, the things they discussed in their groups. I'm jotting that down on the board, and I hope these are some of the things that they would have noticed. I'm going to try to do it again because you'll see I edited what is available in Desmos. I didn't like the 50% because then I just feel like I just keep saying 50%, right? If we increase by 50%, we end up at 150%. If we decrease by 50%, we end up at 50%. So I wanted to change the number a little bit and make it 25%. But again, same protocol. We just warmed up. We just got them going. What do you notice, right? So they should have that sort of repetition built up and be able to share out, again, some of the same noticings or similar noticings, but now just adding a little curve to it. Well, what do you wonder, right? So now do another turn and talk. Talk with your friends, your peers, your group mates. What do you wonder? What are some questions you could ask one another? What are some questions you would want to ask me right now? What could I ask you, do you think, on a quiz or a test? And so, again, as they're calling out some of the questions that they came up with based on their discussions in their groups, writing that down on the board and trying to steer them to these questions. And obviously, if they don't ask these questions, I will pose them, and that sort of serves as the basis for, okay, here's what we're going to talk about next. So sticking with those same numbers, I do want to go through all of that, where it's now, okay, what percent of 16 is 20? So kind of going over those same sorts of strategies that they may have used in the do now, showing them how I set it up, how I like to reduce 20 over 16 before cross multiplying, just so that the numbers then are a bit more manageable. I don't know how they do all of these things, but this is what I would try to show them. And ultimately getting to that 20 is 125% of 16, and being able to then remind them of these facts, right? That original 16 is 100%. We increase by 25%, and we end up at 125%. And this idea later on that yes, we can multiply by 1.25, but we'll see that in a bit. And the second question, well, what if 20 were decreased by 25%? And working through that, give them some time to practice, figure that out, and kind of remind themselves as I understand if they've worked through Desmos, they've practiced percent increase, percent decrease already. So I hope they're able to get to the 15. If not, if they need some guidance, I'm walking around, I'm trying to assist, but hopeful that again, doing turn-in talks or group work, they're able to remind themselves of how to do this work. Right, we can check and see how organized they are. Do they have notes to refer back to, etc. And so then same things that I'm trying to point out. Here's what they may have noticed themselves. Right, they might wonder what percent of 20 is 15. Right, if they don't remember that again from their previous work with Desmos, decreasing by 25%, you should end up at 75%. You can multiply by 0.75. We're kind of working through some of those things. So that's where my mind was as I developed this PowerPoint lesson. This question, right? Which operations are used? Again, based on their strategies and things. For me, it's really important that, yes, this problem can essentially be done two ways. Right? I can first find 25% of 16 and then add it to 16. So that is a viable option, but I want to impress upon them that to streamline it, to kind of do this problem in one step, that we can multiply by that 1.25. We don't need to do it in two steps. As long as we understand that relationship, that we're starting with 100%, increasing by 25%, we get 125%. And so the question is basically, what's 125% of 16? So they should be able to, develop that understanding, bring that with them, that we're just going to take 16 and multiply it by 1.25. And that's how we're going to get to 20. Similarly, with the decrease problem, I want to show them the same thing, that yes, you could find 25% of 20 and then subtract that from 20, do it in two steps, but we really want to push ourselves to do it in one step, to remember what's going on with the percents, that we're going to get to 75%. So ultimately, that's what we need to find, 75% of 20, and we do that by multiplying by the decimal form of 75%. Or yes, if 75% it's convenient, you can go to fractions if you'd rather go that route. Those are some conversations to be had, in-house about calculator use, etc. I don't have all those facts, so kind of want to make sure that we're sort of all on the same page. But I want them to understand. I think they can do that. How to do it in one step, right? And this is the other sort of main takeaway. Now that we've done both of these problems, starting with 16, increasing by 25 and getting to 20, and then taking that 20, decreasing by 25% and not getting back to 16. Just want to make sure I have that quick conversation. As we know, this is a common misconception. We just want to make sure that students are not walking away thinking that, right? And again, realizing there's some purpose to the examples that were chosen. So now it's, like I said, that a lot of that's background work, making sure they're familiar with percent change, increase, decrease, and what's going on with the percentages and the way to kind of do those problems quickly. But reminding them of the first objective is to calculate the original amount, given the new amount, and a percent change for one-step problems. Okay, well, if it wasn't just a decrease or by the same percentage, well, then how do I get back? So I wanted to remind them again, right? We did do an increase by 25% by multiplying by 1.25, getting to 20. We did a problem where we decreased by 25%, multiplying by 0.75, and we got to 15. But there's a relationship here that it's just right for multiplying two factors and getting a product. If we want to work backward, we'll think about what you may have done in earlier grades in explaining how that 3 times 5 is equal to 15. Well, you'd say, well, 15 divided by 5 gets me back to 3. How do I know 4 times 5 is equal to 20? Well, 20 divided by 5 gets me 4. Right? So kind of fact checking. And now we kind of use that to more or less work backwards. If 16 times 1.25 gives me 20, well, shouldn't I be able to take that same 20 and now divide by 1.25 and get back to 16? Shouldn't I be able to take that 15 and divide by 0.75, undo that sort of decrease, and get back to the 20? But again, it's all this understanding that 20 is the original 100%, 15 is the 75%. Just right, understanding the inverse operations here of a multiplication and division. So talking through that, then giving them an opportunity to practice. Right, after an increase of 20%, number went in, it came out 36. Well, let's just talk through it, right? 100%. We know we're going to end up at 120%. The quick way to do that is to multiply by 120 or 1.2, 120%, 1.2. So here's our little equation. My hope, checking all these, different sorts of sketches that I did here, right? X times 1.2 does get us to 36. I'm not sure how they're going to tackle it at this point, doing 36 divided by 1.2. Is that something that they're doing with a calculator? Is that something that, they're actually working through in this fashion, right? I don't want to do them. I don't want to make them do long division necessarily. Of course, they can, to come up with the fact that X is equal to 30. I could talk with them about how 1.2 is 6/5. And we could work through it that way, right? Dividing by that 6/5 and such. I don't know exactly how they'll tackle it, but those are some of the conversations, that I could be having with them, depending on their readiness levels and how we as a department, feel we need to push kids. But from what I see in Desmos, the emphasis is really on percents as decimals. But again, it's just a nice conversation, I think, to have with students. So right, that was giving them time to practice. With that, before moving on to objective 2, which again is this idea of multi-step problems, and so reusing what we did before, I want to try to impress upon them that we did do this in 2 steps, and we had this intermediate problem where we intermediate value, right? We started with 16, multiplied by 1.25, we got to 20, and then we worked with that 20 again and decreased it by 25%, multiplied by 0.75, and got to 15. Well, like, do we have to even stop here if we're being asked to do multiple increases, multiple decreases, or one followed by the other? Maybe we don't have to do that. And so I have realized this is incorrect, which is why I kind of am re-recording the video. I realized I made an error. Why won't you erase? Oh, that's why. So just having this question right after 2 steps, we get a little more practice. What percent of 16 is 15? So hopefully, right, if they're not following along, right, they kind of get re-engaged at this point and figure things out, get back with us. Just a simple what percent of 16 is 15. Maybe a little more complicated with the division, but same deal. Cross multiplying 16 times x equal to 1,500. Dividing by the 16. Again, I don't know how they're going to tackle all of this. Is this a calculator problem for them, etc.? And then I just realized that this is 93.75%. So 15 is 93.75%. It is actually 1:15, so I apologize for making that mental error. 93.75% of 16. So, but the question is, right, like how do I get there faster to this 93.75%? And so I want them to try to see that initially we took the 16 multiplied by 1.25 and got to 20. And then we took the 20 multiplied by 0.75 and equals 15. Well, using substitution, I know this is kind of higher level. I wanted to show them that I could take that 20 out and I could substitute sort of its original 16 times 1.25. So that's kind of what I'm doing here. And then talking with them, right? It's an opportunity to go really high level, talk with them about substitution. Talk with them then in this step about the associative property, how we're just regrouping multiplication. We can do that, commutativity, associativity. And now that 1.25 times that 0.75 is where I'm getting to the 93.75. So it turns out I really don't have to look at this intermediate value. If I have to do an increase followed by a decrease, I can just say to myself, well, right, this was 100%. I know that after 100%. I know that after an increase, I'm going to be at 125%. Well, I'm going to multiply by 1.25. And then after that, right, yes, we're back to this being, I know it's interesting, but this is going to be back to another 100%, decreased by 25%. We're going to be at 75%. We're going to have to multiply by 0.75. Well, we can just do that. We don't have to do this multiplication, 16 times 1.25. We don't have to do that. We can just say, well, here are the numbers we're going to multiply. We're going to start with the 16. We're going to have to multiply by 1.25. We're going to have to multiply by 0.75. And then depending on, what the question is, we can either do that multiplication to get 93.75 or just punch it all into a calculator at once and land at the 15. But it's nice to have that conversation, I think, like I said, at that higher level, how we can kind of skip some of the steps and just run through the operations themselves. So then practicing that, I do want to impress upon them that, yes, right, again, we did a couple problems before. You can get this done in 2 steps if you'd like. You could start with the 20 and then decrease by 50%, increase by 50%, multiply by 1.5. You could do that, get to 30, and then you could take the 30, decrease by 50% by multiplying by 0.5, and then getting 15. You can do that, or you might be able to just say to yourself, again, I could start with that 20. I know that increasing by 50%, I'm going to multiply by 1.5. Whatever that happens to be, I know that after I figure that out, I'm going to have to decrease by 50%. I can multiply by 0.5, and that's going to give me the same 15. So yes, it's multi-step because there are two changes, percent changes. There's an increase followed by a decrease. But really, if I ignore that intermediate value of 30, it's really a one-step problem. And then from there, now it's an interesting conversation about how to get back. So this problem, let's practice. 57 comes out. What number went in? That's where I'm saying to them, okay, well, this is X. 57 came out, right? You're starting with X, increasing by 50%. Whoops, what did I do here? Sorry. We're multiplying by 1.5. Then we're decreasing by 5%. So multiplying by 0.95. And that's going to give us the 57. And then from there, they have some options, right? We can multiply 1.5 and 0.95. We can do that and then divide, or we can divide separately. We can say 57 divided by 0.95. That result divided by 1.5, and then that'll give us our original X value. But for me, again, I'm not popping a calculator. This is definitely, by the way, in my opinion, a calculator question. But this is the work I want to see. This is the setup I want to see, the understanding, the increasing, the decreasing, that I don't need these intermediate values, that I don't have to work through and say, okay, well, there's this X, which is 100%, and then there's some intermediate value Y, which is 150% of X. And now I have to take this Y as 100%, and we decrease by 5% to get 95%, and that's 57. Oh my goodness. Well, 57 is 95% of what? And then that same something is 150% of what? Like, that just gets really convoluted in my mind. Again, those are viable, and if that's how kids think, I can certainly approach it that way. But I do think, this is sort of the way to go. And like I said, an opportunity to go sort of high level and tie in some other math with them. Property of substitution property of equality, and the associative property of multiplication. If that's too heavy for them, I guess, right, I'm going to learn a lot about their sort of perseverance, where they're coming from with a lot of these now multi-step problems. So I appreciate that about Desmos. This cool down kind of takes a step back a little bit to kind of wrap up the lesson. And then, I get to figure out from them, conversation at the end where we maybe need to regroup, what the homework assignment is, how we might need to modify it, where to start tomorrow's lesson, where they feel they struggled, what they feel they did well, what we kind of need from each other to move forward. So, I don't know, with that, that's kind of the whole lesson, the gist of it. I do appreciate your time and the opportunity to create this video for you.